exercise 21.3, question 11, part 2. So in this situation, the stuntman actually believes that in any jump, the effect of air resistance is to reduce his distance by 40%. Calculate his minimum safe takeoff speed for this jump. So what we want to think about is when he makes this jump, we know he wants to clear 50, and we can do our calculations about a safe speed, but we know that whatever this distance is here, then we need to reduce that. So let's say, ignoring air resistance, he travels a horizontal distance of x. Well, we know that we need to reduce that horizontal distance that ignores air resistance by 40% to account for the air resistance. So what we want to know, we want to calculate that 40 is reducing this x by 40%, so 0.6 multiplied by this x is still bigger or equal to 50. So even when this x is reduced by 40%, he still clears the gorge. Well, we want the minimum safe takeoff speed, so actually we don't need to worry too much about the inequality. We actually want that we want to calculate when 40% of this distance ignoring air resistance, 60% of this distance ignoring air resistance is equal to 50. So that's what we're interested in calculating. So the safe distance ignoring air resistance is going to be x equals 50 divided by 0.6, which is 250 over 3. Okay, so what do we now want to do? Well, if we're thinking about our projectile, we want to work out, this is 250 over 3, what velocity he needs to launch at, what speed he needs to launch at, still at an angle of 25 degrees, so that the distance that he travels horizontally without accounting for air resistance is 250 over 3. So what do we know? Well, we know the initial velocity is going to be the speed u. Sorry, that's wrong. That should be a sine is our vertical component, and this should be a cosine. So we know our initial velocity in terms of its initial speed u, but we know our horizontal displacement is 250 over 3. And at the point he lands here, the vertical displacement is going to be 0. So what do we know? Well, we know that u equals u cos theta, u sine theta. Actually, no, we know more than that. We know that theta is 25 degrees. So 25 degrees. We know r. We know that r, well, horizontally we want 250 over 3, and vertical we want him to be landing, so we want 0. We also know a. We know that a is 0 and negative g. We don't know t, but we're going to also work with t, and it is this u here that we are trying to calculate. So if we go with the Suvad equation, r equals ut plus a half a t squared, and we substitute these in, what we end up getting is 250 over 3, and 0 is equal to u cos 25, u sine 25, t plus a half 0 minus g t squared. Well, if we take the horizontal component of this, we can solve that for t in terms of u. So just taking the horizontal component here, we get 250 over 3 equals ut cos 25. So t is equal to 250 over 3u cos 25. But now if we take the vertical component, we also have 0 equals u sine 25t minus g over 2t squared. So we have 0 equals u sine 25 times t minus g over 2 t squared. And what we're going to do is we're going to substitute this t into here, so we have an equation that's only in u. We can solve for that u. So what do we get if we substitute that in? Well, we get 0 equals u sine 25 times by 250 divided by 3u cos 25 minus g over 2, 250 over 3u cos 25 all squared. Well, simplifying this a little bit, we can see that these u's here cancel and you get sine 25 over cos 25 is tan 25. So we have 0 equals 250 tan 25 divided by 3 minus g over 2, 250 over 3u cos 25 all squared. And now all we need to do is rearrange this equation for u. So adding the g over 2, 250, 3u cos 25 squared to one side, to both sides, we get g over 2, 250 over 3u cos 25 squared equals 250 over 3 tan 25. Well, we can multiply both sides by 2, so actually this side here is going to become 500. We can divide both sides by g, so this is 3g, and we can square root both sides, and because u is positive, we can just take the positive square root. So we've got this here. We don't need those brackets anymore. Well, if we reciprocate that, we have 3u cos 25 over 250 equals 1 over the square root of 500 tan 25 over 3g. Well, multiplying both sides here by 250 and dividing both sides by 3 cos 25, we get 250, and then dividing by 3 cos 25, we have 3 cos 25, 3 cos 25 multiplied by 500 tan 25 over 3g as our denominator. Just gives us u is equal to this. If you calculate that on your calculator, you end up getting u equals 32.65 meters per second to 2 decimal places. So the safe speed that he needs to maintain, well, to be sure, because I can't remember now if I've rounded that up or down, a sensible speed of something larger than that. So a sensible speed of 32.7 meters per second would be a safe takeoff speed.